Hi guys, Miss Francis here to continue our discussion of Mendelian genetics. Today we're going to be exploring pedigree charts. Well, what exactly is a pedigree chart? Mendel studied patterns of inheritance, but he didn't create pedigree charts, which are a visual representation of those patterns in inheritance. In other words, if there's a trait that you want to know whether or not you're going to inherit, who has that trait, who's going to potentially get that trait. Pedigree charts are helpful in tracing those traits. So how do we read a pedigree chart, and what does that look like? So a pedigree chart has different symbols, where a circle is female, a square is male, and if that symbol is shaded, that means that the trait is expressed. So take a look at this example. They've given us what I like to call a key. They're telling us that a capital W means it's dominant, means that person does have a widow's peak, whereas a lowercase w, indicating that it's recessive, would give a person with no widow's peak. So we can kind of evaluate what the genotypes might be based on that information, based on that key. So we know that in order to express the recessive trait, that person's genotype would have to be homozygous recessive. Now we can trace back what the parents might be, because the only way that the parents could potentially have an offspring that's recessive is if the parents were heterozygous dominant. Now let me address some patterns that are in the pedigree chart. So this would be the husband, this would be the wife. This means that these two people are married, and this line brings us down to their 1, 2, 3, 4 children. So this first set of shapes is our first generation, and our second set of shapes is our second generation. Now back to figuring out the genotypes for these second generation children. Would we be able to figure out what genotypes these kids have? We wouldn't, because they could either be heterozygous dominant or they could be homozygous dominant. We don't know. So in order to evaluate a pedigree chart, there are different clues that we can look for. We want to know if our trait is dominant or recessive, and then we want to know whether our trait is autosomal or if it's sex-linked. Clues that a trait is dominant include that trait appearing in every generation, meaning that there is a shaded box or a shaded circle in every generation. Clues that the trait is recessive means that it skips a generation. So two parents won't have the trait, so two parents will have not filled in shapes, but their child does have the trait, so the child will have a filled in shape. Clues to show that it's autosomal, meaning it's not carried on the sex chromosomes. Well, you've got approximately equal frequency of males and females that show the trait. So let's take a look at two examples. The first one is widow's peak, and the second one is attached earlobes. In this example, we've already been provided with the key. They're telling us that a widow's peak is a W. Whether or not it's a capital W or lowercase w, we don't know yet. But what we do know is that we have a woman and a man who do not have their shapes shaded in. That means that they do not have the trait. Well, that means that that trait must be recessive. Therefore, having the widow's peak must be the dominant trait. Now let's take a look at the attached earlobe example. Again, they're already giving us our key. If we look at all of the shaded in shapes, you notice that our key is telling us that it's homozygous recessive. So that means that having the trait, having an attached earlobe is recessive, whereas having a free earlobe or a not attached earlobe is dominant. Another clue that we know that attached earlobes would be recessive is if we look at this area right here. Do you see how both dad and mom don't express the trait, but one of their children do express the trait? That's a clue that tells us that this is a recessive trait. Let's keep on going and look at another example. Jim and Jill are both tongue rollers. And look at this. They have provided us with a key already. They're telling us the letter T. And we want to know whether or not it is recessive or dominant to be a tongue roller or not. And we're not given the letters. In this case, the genotype. In this case, we need to fill out the genotype. Well, I'm going to take this guess. I'm trying to figure out this puzzle. I'm going to take a guess, and I'm going to guess that having no tongue roll is recessive. So I'm going to label it as lowercase t, lowercase t. In that case, our parents would both have to be heterozygous. This is if tongue rolling is dominant. And then our offspring could either be homozygous dominant or heterozygous dominant. So in this case, that pattern would work. If I were to try and make, if I were to try and make tongue rolling, having the ability to roll your tongue, recessive, then all of these colored in boxes would have the genotype of homozygous recessive. In that case, if both of my parents had the trait and the trait was recessive, meaning that it was represented by two lowercase letters in this case, would I be able to have a child that did not have the trait? I couldn't. All of my kids would have had to have the trait, because in order for the kid to not have the trait, it would have needed the dominant trait somewhere. Therefore, we know that the correct pattern of inheritance is what's written in blue. So in other words, tongue rolling is dominant trait. Now, is it autosomal or is it sex-linked? Well, we can see there are 2 males with the trait and 3 females with the trait. So you could probably take a good guess that our trait is autosomal. Let's look at another example. And here we're not given the key at all. So we're kind of with a blank slate. We need to figure out this puzzle. What I'm going to do is I'm going to use the letters that have a different uppercase and lowercase. So I'm going to use D and a lowercase d. We want to figure out, is this trait dominant or recessive? And is this trait autosomal or sex-linked? Well, guys, take a look right here. We are given a huge clue. Do you see that neither one of the parents have the trait, express the trait? Because neither one of those shapes is colored in. But the child does have the trait. It is colored in. So our trait then must be recessive. Now with that information, let's see if we can go and fill in all of our circles and squares and see if this inheritance pattern works. So I could have recessive, 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 recessive. Now let's see if this would work. Could I potentially have a child that has a recessive trait with parents that don't express the trait? Absolutely. They would just have to be heterozygous. Let's start here. Could that lead to a potentially homozygous recessive child? Most definitely. Over here, I've got a child who doesn't have the trait. So the child would be uppercase D, lowercase d. So this mom would have to be heterozygous for the trait. Over here, I've got two kids without the trait. So they're going to have at least one dominant trait somewhere. We don't know the second one yet. So let's go up here. In order for this parent to have all of its children, right? Because all of these couples' children don't express the trait, but they do have children that express the trait. So they're going to need to be capital D, lowercase d. And therefore up here, we would need to have at least one capital D. Could be capital D, meaning it's heterozygous, or it could be a homozygous trait. And then down here, we know that we can fill in with a lowercase d, because this guy had to have gotten a lowercase d from the mom. So do you see how this is kind of like a puzzle that you're trying to fit all of your pieces into? You need to know whether your trait is dominant or recessive. You need to know whether your trait is autosomal and sex-linked. So in this case, it looks like our trait is recessive. Let's see if we can tell if it's autosomal or sex-linked. Well, 1, 2, 3, 4, 5 women have it and 2 men have it. So we would have to take a broader look at this pedigree chart to know if it is in fact autosomal or sex-linked.